We are the team orchestrators and we are presenting CodeMap. The problem is understanding an unfamiliar code base is time consuming and frustrating, especially during the user onboarding, refactoring, or audits. Developers usually rely on reading the files one by one without a clear picture of how the components actually depend on each other. This lack of structural visibility is the core problem CodeMap addresses. CodeMap solves this by converting a code base into the visual graph. So instead of reading the code line by line, the developers can see how the files, modules, and dependencies are connected. Each node represents a code entity, and connection represents a real relationship in the code. To design this intentionally, we use the Kiro IDE from the very beginning to structure our thinking and document the decisions before the implementations. The user first signs up or logs in using the JWT based authentication. And the reason of choosing the JWT based authentication is that it is stateless and is highly used for the distributed and the scalable systems. Once the user is logged in, the user has two options where to analyze the code bases. First, by uploading a zip file, which allows the faster access, and second, by the GitHub repository link, which reflects the real world development workflows. Supporting both the options gives the flexibility without adding the complexity. After upload, the project appears in a centralized dashboard, which allow the user to manage multiple code bases and revisit the previous analysis. Due to the video time constraint, time limit constraint, we have pre-analyzed a project typescript.zip. Once the user select a project, it generates a graph-based visualizations where the user can view the code base overview, the functions, class, the number of the files the code base has, file contents breakdown, how the different files has the class functions, the name of the class, the name of the functions, the languages that are actually used in this application or in the code base can be viewed easily. The complete code graph of the application can also be viewed easily. Here, the file and the modules appear as the nodes and dependencies appear as edges. This immediately reveals the structure coupling or hidden relationships but that are hard to spot by reading the code alone. At the moment, we are showing a clean and focused graph visualization. This is a minimal graph due to the hackathon time constraint. We did not able to scale the system fully for the medium and the large size code bases. So instead of this, we focused on building the core architecture and the graph model, ensuring the foundation is solid and the production ready in design. To ensure the scalability was not thoughtfully planned, we documented our future scaling and cloud architecture inside the Kiro itself, where we have shown how the systems would scale on AWS, how the Neo4j would handle very large code graphs, how clustering, filtering, and performance optimizations would be added. This shows we use the Kiro not just to record what we built, but to plan clearly and intentionally for how the code map would grow beyond the hackathon. Technically, Go powers the fast and reliable code analysis. Neo4j naturally represents a code as a graph. Next.js handles the visualization and interaction. The choices and trade-offs were planned in the future decisions.md and is correctly documented. Kiro acted as our decision and planning workspace. It helped us to structure the problem, justify the architectural choices, capture the trade-offs, and align the execution with intent. This made our development process clear, explainable, and disciplined. CodeMap has developers understand code base faster by making the structure visible. And with Kiro, we ensured the solution was thoughtfully planned, not just built. Thank you.